Hello, I'm Cameron Pleydell-Pearce. I'm one of the academics here at the Materials Research Centre at Swansea University. I'm actually sponsored by Tata Steel, which means that I get to spend quite a lot of my time working not just in the labs here on fundamental science, but also working with the guys in industry, trying to find out how we will actually implement some of the results that we generate down in the lab. The nice thing about where we work here at Swansea University is not just the beach, which is behind me over here, but also the fact that I can glance out of my office window and check what's happening over at the steelworks as well. This close link that we have with industry is really useful in terms of generating future employment opportunities for the NGDs that we have working on our scheme. And also it allows us to think more carefully about the implications for our research for industry and improving the economy locally and across the UK. As part of my role here at Swansea University, I work within the Steels and Metals Institute. That's a collaboration between Tata Steel and Swansea University, where we have co-located researchers and postgraduates in a single facility. We work together working on fundamental research problems and industrial problems as well, and it's quite an interesting and vibrant environment to be in. Beyond that, I'm also co-director of our Advanced Imaging of Materials facility, where we have up to £7 million worth of world-leading microscopy equipment. This is a facility that all of our NGDs are able to access and use, and we have research programs within that as well, where we're looking at technique development. I've run 3 research clusters. One is around physical metallurgy. Another one is around primary processing, so conversion of raw materials for the steel industry and high temperature processing, so processing of liquid metals, for example, and also one on microscopy. And we have quite a nice time interfacing between the different groups and sharing best practice, sharing information and working together as a team. Some examples of the more applied research that we do, where I have some of my postgraduate researchers actually based in the steel plant, are where we're looking at novel non-contact thermometry methods for measuring the temperatures of refractories up to about 1500 degrees, chasing large 300-ton ladles around the steelworks, and then everything else all the way back down to the lab back here at the university, where we're investigating very, very small pieces of metal in the TEM, for example, at near atomic resolution. And that's, I guess, one of the advantages of being involved in this cluster, is that you can do everything from a very macro scale kind of bucket science type project all the way down to something which is really fundamental and related to the atomic structure of materials.